This week we're going to be talking about finding, acquiring, and QA/QCing data. This is a lot about being able to find the data that's going to work for what you need it to do. There's a couple data videos here on finding data. This one just going through portals, QA/QCing with ArcGIS Pro, and this one with ArcMap if you're still using it. And a lot of this is really about finding the data that fits what you want to use it for. That can be determined by how the data was collected. A lot of the data we use is collected with aerial and satellite photography, good quality. That works out fine. Some of it, not so much. Some of the stuff on the ground, it's harder. That was collected by people surveying. It's hard to determine the quality of it. And that can introduce uncertainty and errors into the data. And then there may also be use restrictions. Most of the data I use is publicly available, so it doesn't have use restrictions on it, but some of it is confidential or privately owned, and at the end of the project, we return everything back to the original organization and then delete our files so that we don't have any chance of violating those restrictions. Downloading the data may sound easy. I did have a data set last year that I had to send a USB drive to an organization, and then they sent it back to me. I haven't done that in a while, but it was so big, almost a terabyte of data, we had to put it on a drive rather than trying to download it over the web. Nowadays, usually we just download it off the web, or sometimes have someone put it up into a Google Drive or similar cloud-based storage for us, and then we download it. Then you go ahead and uncompress it and save it locally. You want to work on stuff locally, either in the virtual drive on the desktop or on your local computer. You don't want to try and access large data sets, especially over the web. Then we need to convert it. Most will come in some type of zip file that may be zip, GZ, tar files, all kinds of things. You want to uncompress it to make sure you are getting down to a geospatial format. We like Shapefiles, TIFF files, IMG files. Those are all standard, nice formats. Otherwise, we can convert it into one of those usually, but sometimes it takes different software to do the conversion. Then we want to QA/QC it. One of the most critical being making sure the spatial reference is correct. That comes up over and over again where we get data that has a wrong spatial reference or an undefined spatial reference. Until we use it, we have to focus on getting the spatial reference. Can't use it until we do that. So checking the spatial reference, I show you that in the videos, and then define it if the spatial reference is missing or incorrect. If it's correct, then we can go ahead and project it into what we need. Okay, that comes a little later. Perform a visual inspection, that means load it up in Arc. Check the metadata, and then perform any other checks as needed. We'll talk more about that over the semester. Then you want to go ahead and project the data into your desired spatial reference. So I put everything into my originals folder when I download it, and I QA/QC it, and then if it's good and I want to use it, then I will move it into the working folder. And if it needs to be projected, or another way of saying that is have the spatial reference changed, I go ahead and do that into my working folder. That way I know that everything in my working folder is good to go and in the spatial reference I want to be using. Then as we use it, you want to go ahead and document your data so that other folks can use it in the future. You'll be really surprised how quickly you'll be producing data that other folks will want to use. Also, the latest data we have is now UAV data. This is just some data that we shot, and you can see how high a resolution it is. This was taken from an unmanned aerial vehicle. And for some things like this is a 10-meter DEM here in the background, and here is the topography that was created with the UAV. So just much higher resolution. This was actually taken from UAV because the professor asked me how close I could get, and so I just flew it a couple of feet off the ground. Anyway, very fun, very exciting stuff you can do with UAVs, and we keep getting more and better data available through technology. Okay, we've talked a little bit about file formats, but now things get a little more complicated. I mentioned that Shapefiles are the most common. Probably 90% of the data that's out there is in Shapefiles, which is great. They're easy to use, very well supported. However, every once in a while you may come across an E00. That's an old format from Esri. It's a compressed coverage file. I think only ArcGIS products will convert that to a shapefile. There are spatial data transfer standards, SDTS. This was a US government standard that failed. And you'll still see it though. Some US government data is still in it. Dxf is AutoCAD. AutoCAD is used very heavily in GIS, especially for things that require 3 dimensions like utilities underground. They use Dxf Files. That does not convert as well because the CAD world is a very different place and they handle data very differently than GIS. So plan on spending some time with that one. Then there are CSV files, or comma separated, and there's really a whole family of these. Could be commas, could be tabs, delimited, could be spaces, semicolons. You'll see a whole variety here. Regardless, all of these can be converted into a CSV in Excel and then brought in as XY data into ArcGIS products or other GIS packages. And TXT is another one that's similar, can be all kinds of different things. All right, so, this is in ArcMap. We haven't seen this in ArcGIS Pro. These event layers, if you see them, you want to avoid them. They tend to crash. Raster file formats, there's, as I mentioned before, there's over 100 different ones. This is what we really need to know. We need to know that it's raster data, the number of rows and columns of pixels, because that determines the size of the data, the coordinates, which we'll talk about in a second, and then the spatial reference, or the projection and datum that it's in. Again, recommend IMG and TIFF with ArcMap and ArcGIS. There's a lot of other formats, but if you put it in those 2, you'll be pretty happy. Okay, so once we have a raster data set and we have the spatial reference for it, the projection, the datum, we're 2/3 of the way there. The problem is because rasters are grids of values, they don't have coordinates built into the raster. This is why formats like GIF and PNG don't work, because they aren't referenced to the surface of the earth. We have to have something to reference them to the earth. And periodically I will get images like a JPEG that isn't referenced to the earth. Now we can bring it into ArcGIS or another GIS application and we can georeference it, is what this is called, where we pin the corners to the earth. So in this case I've got the upper left and lower right hand corners that I can specify coordinates for. Okay, and there's 2 ways of doing that. One is to specify typically the upper left and lower right corners of the raster. The other one is to specify the upper left and then the width and the height of pixels. So if you have the width and height of the pixels and then you have the number of pixels vertically and horizontally, then you can compute how large this image is on the earth. Okay, so there's different ways of doing that. Now, with JPEG and with TIFF files, there's something called a JPEG world file or a TIFF world file. Once you georeference a JPEG, it may have a world file with it. Again, if you convert it to an IMG or a TIFF, you don't have to worry about that because that data is held with the file format. Okay, now on top of these formats, there's a whole set of much more complex formats for raster and vector data. These combine together different types of data, raster and vector, into one quote-unquote file. And I say quote-unquote because you have things like a personal geodatabase, which is an old format, not recommended. It's highly volatile. I've seen them get corrupted very quickly, and then you can't use them at all, so it destroys your data. I don't recommend them. And then there's a file geodatabase, which is really a folder, and we've seen this a little bit, and then the folder has a bunch of stuff in it that you don't want to access or change things in. Leave the folder alone, treat it as a file. Now Esri has made this more open, but this is a commercial Esri format. You need to zip the whole thing and then unzip it at the other end to distribute it like other folders that have data in them. And it is a good option for things like a town, because a town would have all this different types of GIS data. They can put all their GIS data, including raster and different types of vector, together in one file geodatabase and then access it from Arc. However, you really have to be an ArcGIS user to be able to use it. So only recommended in certain situations. KML is not a GIS interchange format. The reason is once you store data into it, it's very complex, it can be difficult to get the data back out again. So if someone asks you to build a KML for Google Earth, which is where it's used, you can take your GIS data, convert it to a KML, give it to them, but then hang on to your GIS data. Keep your GIS data in usually Shapefiles with KMLs, but KMLs can also support rasters and even support three-dimensional data. A KMZ is just a zipped KML. In fact, you can rename the KMZ, the extension .kmz, to .zip, unzip it, and you'll see that there's a KML inside of there. So that's easy to get to the KML. And then there are tools in ArcGIS and other products to pull data out of the KML, but again, doesn't always work well. Okay, sources. There's so many sources, we can't list them all. And we would want to because they keep changing. These are some of the ones I commonly use, especially Natural Earth for global data. It's great. It was built by an HSU person. I used it before I got here. The United Nations has a lot of data, and their affiliations, affiliated organizations have a lot of data for global stuff, especially on humanitarian issues. The Central Intelligence Agency for the United States, might surprise folks, that they have a lot of GIS data they put out there for free. Like this World Fact Book, which can give you starting information on any country on the planet. There's also National Map. This is the place where the US government is trying to centralize all of their GIS data. It's gotten a lot better. It used to be almost unusable, particularly by multiple people at the same time, but it has gotten better and I have been able to use it. NOAA, USGS, and NASA are great. They provide us with tons of information, lots of great GIS data. It can be challenging to find and download sometimes, especially NASA, because NASA likes to make things new and different, and that means they're incompatible. The USGS standardizes a lot of the data and puts out a lot of great data as well. They manage the Earth Explorer one. And then there's lots of individual agencies out there. At the same time, there's also state, county, city websites. Arcata has a GIS webpage with GIS data on it. And then there's commercial sites. Those tend to charge for their data. And other countries can have data as well. I just caution folks to work internationally with other countries unless you are from that country or know someone from that country, because they're going to have different ways of doing things. They may even have different file formats, different standards. They're going to do GIS in a different way, so be ready for that. We do have a data hub, but it's currently down for maintenance. It has a little bit of local data. And then I go through some of these. Oh yeah, Eros Data Center. That's another one you can get satellite data from. I haven't been there in a while. And one of the things to do is to watch your links, because every year I have to go through these links, and every year there are things that have changed that don't work anymore. Here's a whole list of other ones. There's lots of data out there. These are all at the national level. Again, National Map is getting better. California has a lot of GIS data available. However, it can also be difficult to get to because there's so much data, and it tends to be put in these portals with tons of data. So that can be kind of a pain. But there's a lot out there for California. Okay, so different types of data. Some of this is really dated, like the digital raster graphics. These are the old 24K topos. These were actually scanned, and you can now buy them and download them, and they're the old ones, so they're out of date, but they still have a lot of great information that isn't available on any other source. At the same time, you can get digital versions as well, so different versions of the topos available. Okay, and here's how you get them from CalAtlas. All right, digital line graphics. So these are the DRGs that have been converted to vector data, and you can get those through the USGS, the individual layers, or maps of them. DEMS, we use a lot of DEMS, and the USGS Earth Explorer has 10-meter DEMS for the entire country and 30 meters for the entire world. Great resource. Coastal Mapping Lidar project, which was done by NOAA. We can get Lidar 1-meter DEMS for anywhere within a kilometer of the coast, and you can see here for Humboldt quite a bit further. And Lidar is one you can find for a lot of places. You have to dig around to find it Open Topography is another website that I get LiDAR data from. If you are going back in time and want to do changes over time, the DOQQs or digital orthoquads are the old black and white photos that go back into the 1950s. And there's some areas of the US that's the only aerial photography that we have from them until very recent times with NAPE. NAPE is being done, I believe, over the whole US since 2003. It's RGB, so it's color, 1 meter, very high resolution, great stuff. It's another excellent data set. Landsat, it's only 30 meters, so it's not as high resolution as something like NAPE, but it's also flown twice a month now for not quite 1970, so over 40 years of Landsat data, which is just amazing. And here are just some examples of Landsat. Glovis is another site. This is one where you can get Landsat data. You can also get it off of USGS Earth Explorer. The National Wetlands Inventory. So good data set, huge level of complexity, can be challenging to get through. And like a lot of national data sets, it may be missing some detail at the local level. So that's always a challenge with these national data sets is it going to have what you need if you're working at a small extent? Or do you need to go to a local resource or even go out in the field? If you're working at a large extent, state or national level, of course, you want to be using these national level data sets. The NHD is another one. It's an excellent data set. Again, especially at large extents. Small extents, you may have to get DEMS and make your own. We'll do that in class. National Atlas is gone. The data is still out there. It's under National Map and you can find it if you search for it. But this was a great site. Really liked it, but it's disappeared now. The NLC, National Land Use Land Cover data set is another one. I haven't used it much. I have used the NLCD one. This we use a lot. National Land Cover data set. And it covers the entire country at 30 meters. Now, this is one that has a high level of uncertainty. In fact, they talk about it being only 50% accurate. Well, what they've done is they've taken each 30-meter pixel across the entire country, and they've labeled it as open water, ice, snow, low residential, deciduous forest, evergreen forest. So you can imagine how many of these pixels have, multiple cover types in them. And that's why that uncertainty is so high. It's not that it's wrong, it's just that it's picking the dominant vegetation or dominant land cover, and it's going to get that wrong periodically. So, yeah, it's not very good for determining the actual land cover on the ground. You should be out doing that yourself or with high resolution data. But to look at large extents, and especially land cover change over time, like urbanization, deforestation, over long periods, this is a great data set for that. There's national California land cover, census data. Census data is very complex. You want to spend some time with it. As with any data set, when you're coming to a new data set, plan on spending some time finding what you need and then going through and understanding it and working with it. Especially with the census data, I recommend working with someone who's familiar with it. All right, so that's just a little bit of an overview, and what I want to do is encourage you all to go out and look for your own data. If you're looking for a shapefile of something, you can just type something like oil wells shapefile. And you might be surprised how quickly you can find data on oil wells. Now at the same time, it might take quite a while to actually get to the data. Here I'm at Esri, shapefile, download, did that work? That might have worked. I can't really tell. I said download, didn't I? Yes. Download. It might just be taking a while. So sometimes you can do that very quickly. Sometimes it takes much longer. Have fun.